There is a specific moment waiting in the deep future, written into the fundamental laws of physics, when the universe will do something it has never done before. It will run out of light. Picture the exact fraction of a second. The last star in existence dies. It will not be a violent explosion, but a quiet, fading ember. And then, nothing. No stars, no galaxies, no meaningful sources of heat or structure. An emptiness so profound takes over that time itself loses all meaning. There is simply nothing left to measure it against. Just a silent, freezing void stretching into infinity forever. This is not science fiction. It is the inescapable mathematics of reality. The cosmos will not end in fire. It will end in perfect silence. And according to modern physics, this is exactly what awaits us. The universe is already dying. To understand the end of the universe, we must understand a horrifying truth about the present. The universe is already dying. Right now, we are living in the stelliferous era, the era of stars. It is an age of light, heat, and explosive energy. But this era is an illusion. It is a temporary spark in an ocean of dark time. The engine driving this decay is the most unforgiving rule in all of physics, the second law of thermodynamics. In simple terms, the second law states that in a closed system, entropy always increases. Entropy is a measure of disorder. It is the reason a hot cup of coffee always cools down to match the room around it. Energy naturally disperses and seeks equilibrium. Stars are fighting a desperate, losing battle against entropy. A star is essentially a massive nuclear furnace, taking concentrated hydrogen and burning it. It radiates its energy out into the freezing emptiness of space. But that fuel is finite. The universe was given a strict budget of usable energy at the Big Bang, and no more is being created. Every photon of light that hits your eye is energy being spent, never to be recovered. The universe naturally and irreversibly moves toward disorder. It is a wound-up clock that is slowly ticking down. The galaxies you see in telescope images are not permanent fixtures of a static cosmos. They are temporary campfires in a cold, dark forest. And the wood is running out. The last stars. Fast forward into the deep future. Billions of years from now, the gas and dust required to forge new stars will be completely exhausted. The grand, violent nurseries of the cosmos will go dormant. The star-forming era will end. As the eons drag on, the only surviving stars will be the red dwarfs. These tiny, cool stars are incredibly efficient. Because they burn their fuel so slowly, they can live for trillions of years. In this distant era, the night sky will not be a brilliant tapestry of diamonds. It will be a faint, dim expanse of dull red embers, separated by unimaginably vast oceans of expanding space. But even red dwarfs cannot cheat entropy. Trillions of years pass like dust. Entire civilizations could rise, flourish, and vanish between the sentences of this cosmic timeline. Eventually, the universe will reach a milestone that is almost impossible for the human mind to process. The final red dwarf will exhaust its last reserves of hydrogen. Stars do not die peacefully. They fight against the universe itself. But eventually, the universe always wins. This last star will not explode. It will simply cool. It will shrink into a dense, dead husk known as a black dwarf, a frozen sphere of carbon and oxygen radiating no light and no heat. When the last star fades, the universe will plunge into the degenerate era. The cosmos will go entirely, permanently dark. No biological eyes will ever look up at a glowing sky again. For the first time since the Big Bang, the universe becomes a place where darkness truly dominates. The black hole era. With the stars dead, the universe becomes a graveyard. The cosmos is now populated entirely by stellar corpses. Neutron stars sweep the void with invisible magnetic fields. Without the light of stars, the universe is brutally cold, hovering just fractions of a degree above absolute zero. But the undisputed rulers of this dead universe are the black holes. Galaxies have long since dissolved, their inner stars swallowed by the supermassive black holes lurking at their centers. These black holes are the ultimate hoarders of the cosmos, from which nothing classically returns. In the black hole era, these monstrous entities wander through a completely lightless void. Mostly, they exist in total, terrifying isolation. Yet even black holes are not immortal. In the 1970s, physicist Stephen Hawking discovered that black holes slowly leak particles into space. This process is called Hawking radiation. The black holes are evaporating. But this evaporation is agonizingly slow. For a supermassive black hole to evaporate, it will take a googol years. That is a 1 followed by 100 zeros. In this unfathomable stretch of deep time, the black holes shrink. As they lose mass, they get hotter and evaporate faster. Finally, in its last moments, a black hole will explode, releasing a burst of high-energy gamma rays. Imagine the scene. A universe that has been pitch black for a googol years. And then, a sudden, blinding flash of light as a black hole dies. A microscopic echo of the Big Bang. And then, darkness again. Eventually, the very last black hole in the entire universe will evaporate. The final flash of energy will disperse into the infinite void. The monsters are dead. The graveyard is empty. The death of time. We have now reached the dark era. Here, science becomes deeply philosophical and profoundly terrifying. The universe has achieved what physicists call heat death. This means that usable energy has become so evenly distributed that no meaningful work can occur anymore across the infinite expanse of space. Maximum entropy has been achieved. The universe is now nothing but a tenuous mist of photons, neutrinos, and electrons, stretched across a space that has been expanding for countless trillions of eons. These particles are so unimaginably far apart that they will never interact with another particle again. Atoms themselves may eventually decay into isolated subatomic particles. There is no structure. Gravity still exists, but the universe has become so empty and expanded that almost nothing remains close enough to interact. There is no memory of the stars, or the planets, or the black holes. The universe is suffering from a profound, irreversible amnesia. It is a cosmic flatline. Without structure, there are no observers. Nothing can happen. The universe is entirely and permanently locked in a state of perfectly uniform, freezing exhaustion. And because nothing can ever happen, time may lose all practical meaning because nothing changes anymore. Time is simply the measurement of change. We experience time because things happen. A heart beats, a planet orbits, a star burns. But in a universe of maximum entropy, where all large-scale change has effectively ceased, there is no change. No events occur. If nothing changes, how can you measure time? You cannot. In the heat death, time becomes an empty concept. The clock does not stop, the hands simply dissolve. The cosmos is trapped in an infinite, unchanging present, not with an explosion, not with a final battle, but with infinite darkness stretching forever. Is there any escape? Is this truly the end? Is the heat death the unavoidable fate of everything that is, was, and ever will be? While mainstream cosmology points to heat death as the most mathematically probable conclusion, physicists do debate other unsettling hypotheses. There is the Big Rip, dark energy. The mysterious force accelerating the expansion of the universe could become so powerful that it overwhelms all other forces. It would eventually tear apart star systems, planets, molecules, and finally, the very fabric of space-time itself. There is vacuum decay. It is hypothesized that the underlying quantum fields of the universe might not be in their lowest possible energy state. If the universe randomly quantum tunnels into a lower energy state, a bubble of true vacuum would expand outward at the speed of light, instantly rewriting the laws of physics and erasing all matter it touches. And then, there are the bizarre implications of infinite time. Given an infinite amount of time, pure statistical probability suggests that particles could randomly arrange themselves into complex structures. Physicists call this the Boltzmann brain paradox, the terrifying philosophical idea that isolated, self-aware brains might spontaneously hallucinate into existence from the quantum foam, only to instantly dissolve back into the void. These ideas push the very limits of human logic, straddling the line between theoretical physics and pure philosophy. They are not guaranteed. They are whispers in the dark, the cosmic spring. When you look at the terrifying scale of cosmic time, it is easy to feel insignificant. But there is another perspective. We exist in a vanishingly rare window of cosmic history. We are awake during the only brief moment where stars shine, planets form, and life can wonder about its own existence. Everything we know and love exists during a tiny flash of light, sandwiched between two eternities of darkness. For a brief moment, matter in the universe became conscious enough to witness the stars before they vanished, before the lights went out. One day, the stars will burn out. One day, the universe will go silent forever. And the terrifying part is, it probably will not even notice we were here.